Hello everyone, welcome back to the channel. So today we'll solve the daily problem of Leetcode challenge. So what is the problem? Problem is that restore the array from adjacent pairs. And it is a medium level problem. And let's read the problem. So there is an integer array nums that consists of n unique elements, but you have forgotten it. Okay. However, you have to remember every pair of adjacent elements in nums. Okay, perfect. Okay. You are given a two-day integer array, adjacent pairs of size n minus 1, and where each adjacent pair of I is equal to ui and ui comma vi, which indicates that that the element ui and vi are adjacent in nums. Okay. Uh, it is guaranteed that every adjacent pair of elements nums I and nums I plus 1 will exist in the adjacent pair either as nums I, comma nums I plus 1 or nums I plus 1, comma nums I. The pairs can appear in any order, okay, any of them. Okay, so return the original array nums. If there are multiple solutions, return any of them. So the problem has given us the adjacent pairs, which is the 2D array of size of n minus 1, and we need to find the original array nums which we have forgotten, and we need to find the nums array using the adjacent pairs. Okay, so here you can see the adjacent pair like that. Adjacent pair have two elements in each row, and it can be more like that nums of I is equal to nums of I plus 1, not that nums of I and the next element will be nums of I plus 1 or nums of I plus 1 or the next element will be nums of I like that. It can be appear in any order, any of these two order. Okay. I hope you guys understood this question, and let's see the examples for better clarification. Okay, you can see the input over here. Address here is given. You can see that the first element is 2, 1, second element is 3, 4, third element is 3 and 2. So output is 1, 2, 3, 4. How can we find the output of this array? This is the original nums array, from where we can derive the adjacent pair. But as per the question, we forget the original array, nums array. So we need to find the nums array by using the adjacent pair. Okay. So how can we find these things? Okay, you can see that we have our nums. We have here two element and the next element or the previous element can be one. Okay, because two is there, and for the case of one, the previous element of one or the next element of one is can be two. Okay, from this case we can say that. Okay, and in this case you can see that 3 and 4 is there. That means the next of 3 can be 4, or the next of 4 can be 3. Both will be occur, any of them can be occur. Okay, so here you can see 3 has another edge, another adjacent node, or the adjacent, you can say the another adjacent element, which is 2, or it can be appear before the 3, and it can be appear after the 3. Okay, so how can they got this? See, 1 is the root element. Why 1 is the root element? Because 1 has only one what can I say, one node or one element attached to it, because you can see one is used for the one time over here, and one is there. After that, as I said earlier, that one has only one element. That means it can two can happen, two can take place at after the one element or the before the one element. So as the question, it occurs in the after one element, then after 3. Okay. So as we see earlier that 3 has 2 and 4 as the adjacent nodes or adjacent elements. Okay. So after 2, the 2 is used. After 2 we can only use 3, or before 2 we can only use 2, but before 2 we already use 1. That's why after 2 we need to use 3. So we have used 3 over here, and after that, after 3 we have only one element left which is not visited yet, which is 4. So this is how we have got our answer. This is the nums, main original nums. Okay, so that is it. So let's see the next example. Okay, the next thing is this is the adjacent pairs and 4 minus 2. Then the thing is 1 comma 4 minus 3 comma 1. So here we can see that the root element can only occur for one time. So 4 cannot be a root element. We need to find the root element first before proceeding anything else. Then 1 cannot be then minus 2, yeah, can be a root. Minus 3 can be a root. So root can be minus 2 or minus 3. So we can have two multiple answers. Okay, so let's see that how can we solve this. Let's say 2 is our first root. That means it is a root, and after that it's connected with 4. So 2 after that is 4. You can say 2 minus 2, then it's 4. And 4 is connected with 1, so let's push back the 1 over here. And after 1, 3 is connected with 1. So let's put the minus 3 at the end. And this can be our answer. Also, you can use the minus 3 as the root element. Then you can get this answer. And for this case, example 3, you can see that we have only one element in the adjacent sphere. That means we have only two nodes mainly. So we can just return the node value, and this is our original array. So, how can we solve this? This is the question right now. So, we can see that we need to visit every array only, every element only once. Okay. So, before that, we need to find the root element. So, how can we find the root element? Okay. So, how can we? Let us see. We can create that any hash map, like any graph that we have connected a graph, and after that we will see that when the element is which is the root element, the root element, the condition of root element is it must have only one node adjacent to it, or the next thing is after that, yeah, we got our root element. After that, what we can do, right? We have got the root element, then what can we do? Okay, so we need to check for we need to check for which is connected to the root element. We just put this at the end. Then after that we check that suppose this is at minus 2. After that we got the minus only 4. Then after 4 we'll check that 4 have any other options, any other adjacencies, adjacent node. Yeah. If yes, then we'll put that and we'll do it forever to get the original node. And let's see how can we solve this. So let's create an hash map, which is our unordered map. Okay, so we'll take the integer and the vector integer. Uh, Vector integer. Okay, so let's call it as graph. Okay, I hope you have understood what is map, and let's fill it up. Okay, and let's take it auto because it will set the auto value. And let's take is X will be better, and then adjacent pairs. Uh, okay, so how can we add the adjacent nodes? Okay, so we can like do like this. Add X of let's take it as edge because all these things are edges will be of a graph. Okay, so edge, we have two elements only, so edge 0 dot pushback will be uh, edge of 1. And another thing is graph of edge 1 dot push back will be edge of 0. So this is how we have created the graph, and then what we need to find? We need to find the root value. Okay, what is the root over here? So let's take as any default value. We have taken the 0. So let's take auto, then maybe iterator will be there, and the graph is there. Okay, so how can we check this? This is a root or not? If and only if and only if that it dot second dot size is equal to 1, we'll consider it as the root equal to it dot first will be the root, and we'll just break here. Okay, we have got our root. Then what can we do to get the answer? We can make the, you can see that vector int will be returned. So let's take a vector int and let's give answer, and we'll add a DFS over here to check to make the whole array, and at the end we'll return the answer. Okay, so we need to create the DFS for the traversal. So let's create an DFS. After that, we'll add the parameters over here, and it will be a void maybe because it will not return anything. Let's take a node, and what we need? Mm, we need the graph, another map, and vector int. Okay. It is a graph. Okay. Then what do we need to add? Okay. Answer we need. Then also I think we need to take the previous element to check that this is already visited or not. So what can we do? We'll just add the node to the answer array. Then we can, what will be the node? This is the node, and then we'll just do the same thing. We'll just check it for the other neighbors. Okay, let's take the neighbor of the graph. Okay, okay, of the graph of node. Okay, so we need to check that. Okay. If the neighbor, if the neighbor is not equal to the, what you can say, previous value, then let's have the DSA for the neighbor. Okay, so then check for neighbor. Then let's give the graph. Then let's give the answer. Let's give the previous will be the, okay. So previous will be the node because the current node will be the, for the next recursion it will be the previous. Okay. So we have done with the DFS, and then check for the DFS over here. Okay, so uh, int node. Okay. Node will be there for the int. Okay, then give the root. Then I guess graph answer previous. Okay, graph answer previous. We have given. Let's see. Let's give the infinite value. So we'll not get um, any kind of errors or other value. So okay. So I hope we have done with this code. Let's run the code. Let's see, is there any error or it is the correct answer? Okay. As you can see that this is accepted and every test case are accepted by our code. So what we have done, we have told, we have made a graph and given graph hash map. Then we have find the root which only have the one adjacent node, and then which what we have done is that we have used the DFS traversal to get the other elements, and then we add it to the answer value, and the answer value will be returned as the answer. Okay. So let's submit it. Let's submit it and let's see is there any test case getting error or not. Okay. Wait for a second. Oh, I'm getting time limit exceeds. Let's wait for a second. I'll fix this error. So what we have done wrong to get this error, that I hope in this case we need to add an ampersand to store the addresses every time and update it, and I hope the code is okay right now. So let's submit the code once again and let's see. Is it accepted or not? Okay, this is an accepted code, and let's find out the time complexity and the space complexity over here. So for this case, we have just checked all the arrays, all the elements of the given arrays. So O of n is the time complexity from here, and in this case, we just check again the all elements once. Then for the DFS, we just check all the unknown visited elements. That if the element is visited already, then we will not check it once again. That's why the time complexity will be, you know what? The time complexity will be big O of n. Okay, am I right? Yeah, I am right. So what will the space complexity? So for this DFS case, we just using a recursion, and it will take a space stack. That means the stack space will take up to big O of n time, big O of n. So we can consider the space complexity of this code is you know what, big O of n. Okay. I hope you guys have understand the code and the question and everything in this video. And thank you guys for watching this video. I'll see you in the next time.